Hi, everybody. I'm Megan Kurka. I'm a data scientist at H2O. And I was going to talk today about automatic documentation, and this is one of the features in Driverless AI. So first off, I just wanted to showcase this screen you're probably familiar with. This is Driverless AI experiment screen. Has anyone tried Driverless AI before? Yeah? Okay. So some of you have tried this and you see this screen. So what I'm really going to focus on is this download experiment summary button. And this is where you can access a document that's describing everything that's done in this experiment. So whatever your data looks like, whatever your experiments run, it's going to be custom for that. And you'll be able to access that automatically from the download experiment summary button. So one of the reasons why we wanted to create automatic documentation is because there's a lot going on with Driverless AI under the hood, but it's not clear necessarily to the end user. You'll get some information in the progress bar of what's happening, but it can happen very quickly and you may not know about it. So the first step that Driverless is going to do is some data processing. Here it's going to detect what's the data type. So is this a text column? Is this categorical? Do I think it's categorical or an integer? It could be both. Is it time? So it's going to detect all of these data features. And then the next step, it's going to do something called model and feature tuning. And this step, it's actually going to see what's the best algorithm and what's the best parameters for this algorithm, as well as start adding new features. You're going to see that running. It's called model and feature tuning in the Driverless AI. And then the next step, once it's done with that, the goal is, okay, it knows the best kind of algorithm, the best features. Now I want to focus on feature engineering. Is anyone here familiar with feature engineering? Okay, awesome. Great. So feature engineering, just for anyone that's not familiar, it's this idea of how can I shape my data so that it's optimal for machine learning. So for example, zip code, it's numeric. Right? The driverless is going to think it's numeric, but maybe that's not the best representation of zip code. Instead, maybe I should think of new features. So how many people are in each zip code? Maybe that's a helpful feature. Or how likely is it that somebody churned from this zip code? There's all of these different ways to represent the data. And this is typically what a machine or a data scientist will spend a lot of time on. And this is all going on underneath the hood. You'll see these features coming up in Driverless AI that you don't recognize. These are the ones that are automatically being generated by Driverless. And that'll be this iterative process we use in a genetic algorithm for that. Then the last step is a final model training. So we find the best features, we know the best algorithms, the best parameters. Let's make this final model. That can be a single model, or it can be a bunch of models put together with a stacked ensemble, it's called. And that can be configured based on your settings. And then lastly, we'll give a scoring pipeline. And this will be for productionizing. It'll be Java or Python, depending on your settings. And it's completely independent of Driverless AI. So this is all that's happening underneath the hood, and there's even more. But it's not necessarily clear to the end user. And we use Driverless AI, the AutoDoc feature, not only to document that and give you more insight, but also to try to automate other pieces of the data science workflow. So model tuning, algorithm selection, feature engineering, those are all typical pieces of the data science pipeline. But another one is this post-processing. I have this model, but now I need to document it for my team, maybe for regulators. So there's this documentation process that happens at the end that we wanted to also automate. So when you click on Download Experiment Summary, you're actually going to get a zip file. We're going to take a look right now, but it's going to have one of the objects in the zip file is going to be a Word document. So let's open one. So if you go to H2O.ai and you click Download Experiment Summary, there's a zip file that's going to be downloaded. And we're just going to take a look at one. I don't know if anyone's taken a look, but there's a bunch of different things in here. And they're really just a lot of details about what happened. So for example, there'll be a description of the ensemble model. There'll be the parameters of the ensemble model. There'll be scores. There'll be features, what features were used, a summary. And this is all helpful. This is the raw data, essentially, of what happened, but we wanted to make it easier for a user to understand what's going on. So there'll also be this object called report. And this is going to be the AutoDoc, which is essentially taking all of this raw data and making it into nice formatting, a little bit of text around it, just explaining the whole process in general. Okay. And the report is going to start out with this table of contents. It's going to go through essentially the pipeline I just talked about. And the idea is we're going to give you more insight into what Driverless is doing, but it's also, now you have some documentation around it. Now you can say, why did we do this? Well, we went with the XGBoost model because look at how the light GBM model was doing. It was doing much worse. It's all going to be in this auto documentation. Okay. So the first section is the experiment overview. And this is really just an introduction, high level, very concise, what happened. So for this particular model, I'm trying to predict, if anyone went to the training yesterday with H2O3, we were trying to predict if the Amazon review was positive or negative. So the same use case in Driverless AI. And here's the documentation that comes out of it. So the final model was a stacked ensemble of 2 light GBM models. And it didn't use any of my original features, so 0 of the original features were used. But it engineered 2,096 new features, and it selected 22 of them. So it's doing feature engineering and feature selection. It's a quick sentence to give you a high-level overview of what happened. You'll also get the score. So how did it do on validation? Internal validation, 0.946. So pretty good. No test data was provided. And then some version information. What was your setting? So some really high-level information for the end user to get a sense of what happened. Then we provide some data overview. So this is really helpful, especially too if you're maybe comparing models. You have this data overview that's built in. So you can see very clearly if the data is slightly different, what did it look like. We want to add more information here too. Was there any missing values, for example, in your test data that the training data didn't see? So we want to add more details around this, maybe some distribution graphs. But it gives you an idea of what does the data look like. There's numeric columns, there's categorical, there's Boolean, or there's time. So quick summaries. The other thing it's going to tell you about is something called shift detection. So Driverless AI by default is going to check for any shifts in the training, validation, or testing data. So if you provide any data set other than training data, it's going to check if there's some shift in the distribution. I'm not sure if anyone's familiar with this. This is actually happening very quickly in Driverless AI. And let's take a look. So if there is a shift detection found, you're going to see this particular graph and some details. So for this use case, there's a significant difference between training and test data distribution for the feature age. And I can see in blue it's training and green it's testing. So there is some difference. There's overlap, but it's definitely different. And Driverless is going to alert me about this because it may indicate that I shouldn't use age as a feature, because age is very different in my test data. And the way we do this is we actually treat this as we build a bunch of little models in the beginning. So we say, could I separate my training data from my testing data if I just looked at age? And so I'm going to build a whole model. The goal of the model is it in train? Is the record in train, or is the record in test? And I'm only going to use age as my feature. Now, if I'm accurately able to find that, in this case I have an AUC of about 0.85, so it's definitely able to start detecting train or test. If it's pretty accurate, then I know, for whatever reason, age is different in my testing data. Now, this is different from the traditional approaches where maybe we look at averages. The reason why we go with this one is you could have, the average could be very similar between train and test, but the distribution could be very different. So this is a quick way of quick way to check, can we differentiate between 2 data sets based on features? And Driverless AI will alert you in the GUI as a notification, but it will also come up here in the automatic documentation. Okay. The next section is methodology, and this will go a little bit more detail into the pipeline that we were talking about. So each step is discussed. There's ingesting of data and detecting column types. There's some feature pre-processing. Driverless actually doesn't ever use any non-numeric data. So any categorical data, any text data, it's always been pre-processed into numeric data before it builds a model. Then it does a model and feature tuning step. So in this case, it found the optimal parameters for our XGBoost and light GBM models by training models with different parameters. And it's evaluating how does it do in this internal validation data in terms of AUC, which is my score, to see if it can find the best algorithm, the best parameters. Then there's feature evolution stage. In this section, it built, as we discussed, 2,096 features over 41 iterations. So it did build a lot of features. I only gave it 4 original features, and it built from that 2,096 features. And it tells me a little bit about my final model, which is 2 light GBM models. And here I have this table, which is just giving me how long did each basic step take and how many models were built for each step. So you can kind of get an idea of the scope of what Driverless AI is doing. Okay. The next section is validation strategy. So a lot of the metrics shown in the experiment on the Driverless AI page is all internal validation. So if I just go back quickly, you're seeing all of these scores up here. This AUC, there's an AUC down here. These are all in terms of internal validation data. And Driverless AI does not require you to give validation data, but will never score on its training data. So the way it does internal validation is dependent on the experiment and your settings. If you have an IID use case, Driverless may decide to split training and validation, maybe 75 training, 25% validation. If you increase the accuracy, it may decide to do 3-fold cross-validation or 5-fold cross-validation. So this is going to change depending on your settings. If you know that you have a time series use case, it's not going to do cross-validation at all. It will do a training validation split by time. So it'll do a moving window based on time. So this description in the documentation is always going to be changing. And for this particular one, it did cross-validation. So we have a quick understanding of cross-validation, what happened here, what's a visual of what it looks like. So just a little bit of understanding about that. Okay. Then it'll talk about model tuning. So this is that grid search section, essentially. We're going to try the different algorithms. In this case, I only turned on XGBoost or Light GBM. It's going to show me the algorithms, the parameters, and then the scores. So high level, I'm going to see all of the models in order of how well they did, what was the algorithm XGBoost or Light GBM, and their AUC and the training time. I get more details on the side. So for each particular algorithm, what were some of the parameters evaluated and how did that affect the performance? And we're providing more details in an appendix. So we're going to add the full details in appendix. It's going to be later on in the document, but that would be for if you really want to know everything that exactly happened. Okay, then there's the feature section. So here's where the feature evolution is discussed. In the beginning, you're going to get a sense of what transformations are available. So what Driverless does is it has about maybe I would say 20 transformers that can be applied, and these can be applied in so many different ways. I only have 20 transformers, maybe only 10 are valid for this data set, but from those I got 2,096 features. And this will tell me a little bit about each transformer, and that was available for this data set, and what does it do? You're not going to see all the transformers all the time. So if I don't have text data, I won't see text transformers described. If I don't have time data, I won't see time transformers described. So it's going to be custom in the document based on what your data set looks like. If it's not time series, I won't see any lag transformers. And then you're going to get description of all of the top features. So what was the feature name, what's the description of it, and what's the transformer? So for example, we have bag of words. We have a bunch of bag of words features. They're the same transformer. They're just different parts of that. And then we get the relative importance. Okay. And then the last thing you'll see is information about the final model. So you'll get some information if it's a stacked ensemble, what were the attributes of each model, how much were they weighted in the final model. So we have 2 light GBM models. We have one that's 2/3 of the weight, another that's 1/3, and they have slightly different parameters. So we're taking the, the predictions from both models and combining them. And that's how we get the final prediction. And you're also going to get information about how it performs. So what's the ROC, what's the AUC-PR, all of these different metrics for classifying how well does, in this case, Driverless AI separate the positive reviews from the negative reviews. And I'm just going to showcase the actual document. So here I have one up. This is the same one I've just been showing. But this is all going to be documented in this AutoDoc. So here's all the features that were available to me. The top features, a lot of bag of words because this is text. We're trying to predict if Amazon review is positive or negative. The final model, and then we have all of these different graphics around it. So what's the KS metric? What's the precision recall curve? What algorithms were used? What algorithms were available but not used because of my settings or because they didn't do well in performance? And then information about a little more details about the final model. Now this, in the roadmap generally for AutoDoc is we want to add the auto visualization graphics that Leland was showing, so we want to include these in the document on our roadmap. We also want to include interpretation graphs, so if anyone's seen the model interpretation module, we want to start adding that information as well into the document. So that's on our roadmap, and then just generally more information as we go on. And this is fully customizable. The Word document itself can be customized. You can, of course, edit it, change the shape of the size of the graphs, add sentences, but we can also edit it for you. So we've been doing that for certain customers. So this can be customized documents. This is our default document in Driverless AI, but it can be completely customized. So with that, I know we have a few minutes left. I just wanted to pause and see if there are any questions. So let's see. Should I go here? Is that okay? Okay, yeah. So the first one is, okay, so the first one is a driverless question I'll just answer. How does driverless determine the pre-processing to use for non-numeric data? Well, that's actually the whole process. So it's this iterative process. There's so many different ways to represent non-numeric data as numeric, and it's going to try a lot of different ways using genetic algorithm over the course of the experiment to find the best representation of the data. And the best way to determine if the feature engineering is good or not is how does my AUC improve or not in this case. So the only thing that Driverless cares about is improving AUC on some holdout data. It doesn't have any domain knowledge. It's just going to keep trying to improve it. That's what it's doing. The other question was hyperparameters, reference, and AutoDoc. So the hyperparameters are in the model tuning section. You'll get information about the hyperparameter tuning there. Then what is the final score that is displayed? So AutoDoc covers model. Really. So the next question is, can AutoDoc cover documentation related to MLI? That's something we're working on adding. And what is the final score that is displayed in Driverless AI if the result of the best model or a combination? So the final score is the final model you're getting out of Driverless AI. Now that could be a single model or a stacked ensemble of the best models, depending on your setting. Now in the expert settings, you can choose to turn off stacked ensembles, or you can choose to leave it on. So it's up to you whether you want a single model or an ensemble of models, but that final score you're seeing is whatever the final model is by Driverless, so whatever you've configured it to be. Okay, and then the last option is about customizing AutoDoc. So you can customize the final output. It's Word, it's editable, but we do work on customizing the templates for different people. So I think that's it. I'm out of time, so thank you guys.